We discussed hardware, no, various sorts of hardware. So there is a 6-month evaluation of well, 6 months call for top machines in the world, every 6 months. Okay. So there is a list which is made after people submit their specs. So like IIT Kanpur has a cluster. This one is not in top 500, but there was a machine which was on top 500 at some point, past machine. Okay. So so I will discuss what are the big machines today. Okay. So it just gives an idea which kind of machines are being used at present in the world. So top 10 HPC systems. Okay. This for, I think it is also important to know where the world is going. So it's not only for general knowledge, but it is for seeing the trend. So this slide is slightly not, I mean, not probably a bit faint, but let me just speak it out. I just took it from the website top500.org. It's a good site to visit and educate yourself about the trends. So the topmost machine right now in the world is Frontier. Okay, it's in US. It is made by HP and Cray together, HP and Cray, and this is based on GPU called AMD Instinct MI250. So this is a GPU based machine which is giving you the top performance, and it has a CPU as well, but CPU is not where you like to your jobs to be done. It is GPU which is making it very fast. Okay, and it is in called Oak Ridge National Lab. This is one of the, well, probably top 3 supercomputing centers in the world. Okay. So how many cores does it have? It has this many cores. Now the core counting depends. This one, the GPU cores, which I am going to explain soon after this today's this presentation, and there is a CPU cores, right. So GPU also has a computing units and CPU also has computing units. So I think this one you have to be, well, I mean, I need to compute which one they are taking, but you can see it is 8 million. Okay, so huge. So they possibly take CPU, but CPU has, each CPU has something like 5,000 cores. No, sorry, each GPU. So this calculation is, I think, is tricky now. So after a while, probably this will not make too much sense because GPU is well, we see that GPU is a weak computing units, but there are too many of them. Okay. The maximum flop rating is 1.6 exaflop. So it is 1679. Okay. So this is the exas 1.6 exaflop. That means is 1.6 times 10 power 18 operations per second. So this is the first exascale machine. Okay, in fact, it is the only exascale machine known right now. And by the way, this is a peak performance which we computed the way I showed you. No, when power of each CPU, each core multiplied by clock frequency, number of cores multiplied by clock frequency multiplied by number of operations per second. Okay. So it is estimated that way, but when you run a program, then you do not get peak efficiency, you get less, and it is 1.194 exaflop. How much power does it take? It takes 22,703 kilowatts, or which is 22 megawatts. Okay. So now you should compare this number with IIT, well, just compare, let us compare. IIT Kanpur right now takes 10 megawatts of power for the full institute. So this institute, this computer alone needs 22 megawatt, which is double of IIT's consumption, and this is only for the machine. We need for cooling and we need for offices and other stuff. Well, that will be negligible, but cooling also is very significant, but is huge. I mean, even if somebody donates you this machine, you can't set it up, right? You don't have power. So these are the complicated. This power is a major factor in these machines. Second one is Fugaku, is in Japan. It is CPU based, and this CPU their own CPU, Fujitsu's CPU. Each CPU has, I believe, 52 cores, and its peak rating is 532 petaflop. Okay, so is 1/3 of what Frontier has right now. So, now I do not want to get into the details of this, but you see many of them are GPU based. This is GPU based, it is in Finland. Then we have one in Italy, which is again GPU based. You see, this is GPU. This one is also GPU based, Ulta GPU, which is in Oak Ridge National Lab. Same, Oak Ridge has two big machines. Summit is a bit older machine, it has 200 petaflop. Our machine is 1.3 petaflop in IT Kanpur. So, sixth one is US again, it is in Lawrence Livermore National Lab, is in so it is based on IBM, but it has also GPU Volta, right. So, I am going to describe this GPU very soon, okay, in 10-15 minutes. So, we have this one is in China, Sunway. So, they have their own CPU. Okay. So, they have basically developed supercomputing quite rapidly in last 15 years. Perlmutter, this is in Lawrence Berkeley, this thing. No, I think this LNL is I forget, it is in this is Lawrence Berkeley National Lab. Okay. Then this is something else, okay. I do not know the lab. So, this is also US, it is 93. Then Selene, it is NVIDIA's machine, okay. It is NVIDIA's company's machine, which is based on GPU A100, and it is 9th ranked. And this is China, Taihane, 100 petaflop. So, HPC in India, we have 75th, there are 4 machines in top 500, 75th ranked Eravat in CDAC, Pune. Then we have a Tropical Meteorology Center, this is again Pune. Its petaflop you can see is like this 8.5 petaflop, and this is not the peak, but for some codes it gives you 3.7 petaflop. And then we have CDAC again, Param Siddhi, which is 131 ranked, and then we have Mihir, which is weather forecasting. So, this is in Delhi. So, basically you have 4 machines in the top 500. Now, I can just tell you the history. 2007, there is one, well 2007 there is one machine of India which was on top 4th ranked in the world, okay, and that name was Eka. So, it was a surprise for me, I just checked, and the 4th ranked machine was there in that list. It was built by Tatas, it was not public, basically it was not funded by the government, but that was the best we got, nothing to top 500 after Eka moved out of the list. So, you will also see that the ranking will fall every 6 months, because better machines will go in. So, this is very competitive list, and that year you can just check, you can go back, probably China, India probably had 5 of them, 5-6 machines, we did not have many ever, sometimes probably 7. China probably had 1 or something, 0. So, see the rapid effort which they have done over last 20 years, and we have not done efforts at all. So, we have basically been falling very badly in this effort, and it turns out, let me just make another remark, in computing we can compete with the best in the world. Experiment is difficult, people are having nano Kelvin temperatures, okay, and I do not think in India any institute has the nano Kelvin capability, okay, or very high pressures. So, it requires time, no, to build the experimental infrastructure, but these machines you can buy, or well you can with also animate. If you have a great idea, then you can just tell some company to build up for you. Of course, you need to put money. So, great idea, you have to get money for it, and then you do not need to have your own institute company. somebody in Taiwan will make it for you. Okay. So, this does not require you to have the fabrication, it requires a great idea for to build some of this stuff. So, anyway, so this is my frustration that we are fallen behind a lot. So, country wise listing is also very good to know. It's a big war, by the way, like computers right now are the best tools people use, and if you are not in the top league, you are not going to be very competitive in any effort, like car industry, defense industry, anything you take, you will need computers. So, US leads this effort. In fact, US was basically top for long time, but it has a challenge now from China. It never faced challenge of this sort before, but it has now a challenge. But in terms of, well, I do not want to tell in public, but yeah. So, I will tell this bit later. So, 150 machines is a count, okay. But so let us look at the count. China, Germany is 36, Japan 33, France 24, UK 14, Canada 10, Brazil 9, South Korea 8, Netherlands 8, and India is, I do not even know the rank, 8, we are 4. We have 4 machines, so probably in top 50 maybe, but that is what we are. But you also need to see how much the performance share. This is number of computers, but if you have very fast machine, then you have more computing power, right. So, 30% is what is the system share, but in terms of power, because the top machine is 3 times faster than the second best. So, US has 45.8% of the computing power, half of the world's computing power is in US. Now, I can also tell you that some machines are probably not revealed, okay. This list, major defense stuff is probably not in the list. So, these are all publicly reported machines, but we will just go by this, we can't figure out where are some machines hidden somewhere. Now, in terms of applications, now this is a very revealing site chart. 93% is others, 93% no, is vague. Well, it is also true that our machine is not for a specific application. So, I do not know where our machine is not in top 500 machines of this sort. So, you can list as research, or defense will not come, I mean they will not reporting defense here, you see defense is not there. So, defense machines will come here, okay. Or some people say, well, we do not want to list ourselves. So, benchmarking, cloud, software, IT. So, numbers is basically, so there is no special machine for CFD, computational fluid dynamics, or for aeronautics, or for climate. So, climate research, there are 2 machines, but like for example, Indian weather forecasting machine, it is for weather forecasting. So, that is specific for that, okay. So, these are the applications which are listed, but I think this is also revealing 93% is either general or some hidden applications, which is not hidden, but like defense kind of stuff, okay, sensitive applications. Now, so this is an important slide. So, the number of machines with hardware, accelerator wise. So, GPU is the accelerator, no, it speeds up the computation. So, NVIDIA V100 has 61 machines in 61 supercomputers are NVIDIA Tesla V100. Our machine has V100. Okay. So, it is old processor, old GPU, has probably 7-8-year-old GPU. The more well, it is not the most recent, but it is probably 4-year-old A100, which is 27. So, A100 there are, well, now this listing is slightly, there are 3 A100s, different memory. So, this one is 80 GB RAM, another one is 40 GB RAM. So, for A100 I will count all 3 together. Then we have another V100, which is a different. So, look, this V100 comes in different versions. some have more memory, some have less memory, some have some slight change. So, this is another V100. AMD has its own GPU, this one is a very powerful GPU, 10 of them. A100 is 9, this is another A100 is this is the latest GPU by NVIDIA. H100, which we will discuss soon, 5. These are old one, P100, GV100. So, these are K40, these are old hardware. K40 is 15-year-old, I believe, if not 15, maybe 12 something odd years. So, you can see that accelerator is playing a significant role. Okay. So, we need to learn GPU programming. The interconnect. So, the biggest share is by Ethernet switch. So, this is the interconnect. Now, we discussed that switch. So, Ethernet is 86 count, 17%. Ethernet if you combine together is going to be how much? Around 38%. Okay. Then InfiniBand is here, InfiniBand, HDR, Omni, we discussed that. Intel's InfiniBand is a proprietary switch whose details are not told. Okay. You buy, for example, Intel owns chips and you will not get the detail, well, you will get some details, but not all details. But ARM processor is a open source design. So, you can get designs of ARM source, or you can get the instruction sets, how to program, all that is available open. So, some of these are company owned, or some are, I think Ethernet has more information, Ethernet is slightly open. InfiniBand, this is again InfiniBand, Aries interconnect. So, Cray, Intel, I said InfiniBand is bought by NVIDIA now. So, NVIDIA, so they have their own development, okay, and so Slingshot is AMD. So, the number one machine has Slingshot architecture, which is some kind of, well, I do not know the details of it, Slingshot. Operating system, you can see is all Linux. No Windows, no supercomputer runs by Windows. Some are company owned operating system like Cray, Linux is also Linux, but is Cray. So, Cray has done some more work on it. Okay. Like this is again Cray. Okay. So, basically it's all Linux. So, I think you need to learn Linux if you want to be a HPC programmer. Processor generations, these are processors. So, well, I mean there are machines which are fully processor based, right, like the Japanese machine Fugaku. So, some have processors inside, but GPU is the main computing unit. So, the leading processors are in terms of market share, Xeon, which is Intel, no, Intel is quite a big share, Intel, Xeon Gold, Xeon Platinum is here. This is AMD. AMD is now has a very good chip like this. Rome is a very good processor. Okay, Milan. So basically Intel and AMD they are competing right now, and IBM Power is here, is there, and some Japanese CPU and some Chinese CPUs. The number of cores per socket. So, per socket, like CPU, the processor is socket, is called socket, okay, where this chip basically it is this big, if you have seen inside, that is socket. So, how many of them? 24 core CPU is the most prominent with 108 machines, 64, 20, da, 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 da. So, there is nothing beyond, well, I mean, so crossing 100 there is none right now. Okay. So, I think the new AMD processor which is released, Milan is the new processor which is 128 cores, and that is not yet in the list. So, future machines will include that processor. This is Rome, 64 core is Rome, and this is Intel for sure. Our machine has this processor 24 core, but different, well, Intel has many processors, but one such which 24 cores is in IT machine. Okay, so let us look at Frontier. This is the number 1 machine. Okay. So, it has the 4 250, this is a GPU, AMD MI 250, and this is a EPIC processor again by AMD, and they are connected by this internal connections. Okay. Now, this is going to the switch, slingshot switch. Okay. So, that is where it will be, and yeah. So, this is a real motherboard, where these are probably the GPUs, this one's 2, and this is probably the CPU slot. Okay. I do not know, I mean this is, I did not get much information on this processor, this machine detail, well no, not many details are available, at least to me, in the open source. So, let us look at this performance again, just dig little bit inside. So, 1.6 exaflop. So, there are so this Oak Ridge National Lab has Summit as well and Titan. So, these numbers you do not need to worry, but let us look at only the last column. 74 cabinets. So, cabinet is rack, and nodes are A optimized 3rd generation AMD EPIC CPU, and we have 4 256 MI 256X GPU. So, interconnect is sling slot AMD Infinity Fabric, and okay, anyway. So, these are some information. Storage is, look at the storage. Okay. So, this storage is not given, right, I did not see it. So, 250 petaflop is the storage for Titan, which is another machine in the list, no? I think 7th ranked or 9th ranked machine. So, it has huge memory, a hard disk. Memory is also there. Okay. So, I do not remember the numbers, I mean this is, but it has GPUs, this we will see the RAM of GPU in the next set of slides. Let us finish it, then we will come to GPU. So, Param Sanganak, which is our machine, just to compare. So, it has 2 Intel Xeon Pentium 8268. So, each of them has 24 cores and 14 nanometer technology, the best is 2 nanometer technology, and it has 38.5 MB cache. So, CPU number of cores per node is 48, but there are some machines with GPUs, okay, which is V100 GPUs. Okay. So, basically we have 48 cores per node, and RAM is 192 GB in most of the racks, but some racks have 768 GB RAM. This for what? Is for shared memory programming. Okay. 760 is a quite large memory. So, number of nodes with CPU only, this is CPU only 150, but there are 78 nodes with a large RAM, and there are 64 nodes with GPU, okay, and each node has 2 GPUs. So, RAM, total RAM is 28.8 terabytes if you add up together. So, your program, if you are using only CPU only code, should not need more than 28.8 GB RAM if you get all the machine to yourself. Okay. So, when you fire a job, then you need to know how much RAM do I need. Okay. So, we will do that estimate a bit later, but that is another important estimate. How long will it take this program, and how much memory does it need. Okay. So, that is about it for the machines specs.